Welcome, Hornets, and thank you for joining me today. Please be aware we're going to be talking about particle motion, and I have an FRQ style question up here. I do recommend you take a screenshot of it, as I will be taking it off in a moment after we read through it. A particle moves along the x-axis from 0 to 12. The velocity function of the particle is v of t equals 1 plus 2 sine of pi over 6t. When is the particle moving to the right from 0 to 12? What is the speed of the particle at t equals 9? Find the acceleration function of the particle, then find the acceleration of the particle at t equals 6. And is the speed of the particle increasing or decreasing at t equals 6? Explain your reasoning or justify your answer, JYA. Now you'll notice this is a no calculator question. And because it's a no calculator question, I'm not allowed to use one. So we're going to go ahead and start by just taking a look at. If I want to know when the object is moving to the right, I need to find when the velocity is positive. We know that the velocity will be moving to the negative, will be that the particle is moving to the left. So I'm going to start off by finding when is the particle not moving at all. That means that it has a zero velocity. So I'm going to take my velocity function, I'm going to set it equal to 0, and find that the velocity function will be 0 when negative 1/2 is equal to the sine of pi over 6t. So I'm going to stop and I want to think about it from the perspective of when will the sine of theta equal negative 1/2? And I know that on the interval 0 to 12, I will have three values. They will be, after all, keep in mind, pi over 6 would be a 1/2 value, right, for sine. So sine of pi over 6, 5 pi over 6 are positive. Negative pi over 1/2 would be 7 pi over 6, and 11 pi over 6. Well, I then know that 7 pi over 6 is definitely between pi over 6, Mr. Lamb, is definitely negative and is between 0 and 12. 11 pi over 6 is also negative 1/2 and will also be between 0 and 12. But there is one additional value, and that's 19 pi over 6, and that will also be under 12. So between 0 and 12, these would be my values if, and I point out that's if, sine of theta equaled negative 1/2. But we're actually given that this theta is pi over 6 times t. And if I want that to be 7 pi over 6, I'm going to solve and find that t has to be 7, and that is between 0 and 12. Then I'm going to take pi over 6t, I'm going to set it to 11 pi over 6, and I get t equals 11. Now I'm going to check the last one, even though I already know it's too large. It is outside of the 0 to 12, so I have 19 pi, and I end up that t equals 19. Once again, too large, I get rid of it. Now what we're going to do is we're going to make a sign chart. Now a sign chart is simply a number line, and over here we're going to put a vertical line and our function for velocity, 1 plus 2 sine of pi over 6 t. I'm now going to start at 0 and 12. I'm going to locate 7, I'm going to locate 11, and I'm going to choose values that are in between these given values. After all, 7 and 11 are when we will have the velocity 0, there will be no movement, and we want positive or negative. So let's choose values that are reasonable. I'm going to choose t equals 5, and I'm going to plug it in. And I get 1 plus 2 sine of 5 pi over 6, which I already know is 1/2 using my trig knowledge. Putting in the 1/2, I get 1 plus 1, and 2 is greater than 0, which means that this entire interval from 0 to 7 is positive. Therefore, I know that the particle is moving right on this first interval. But what about 7 to 11? Let's go ahead and choose the test value 8. When t equals 8, I'm looking at 1 plus 2 sine, and I'm looking at 8 pi over 6, which gives me 4 pi over 3 reduced. But we know that 4 pi over 3 is really a negative root 3 over 2. So we have 1 plus 2 times negative root 3 over 2, and therefore 1 minus root 3. Since root 3 is a value that is between 1 and 4, and the square root of 1 is 1 and the square root of 4 is 2, I know the result is greater than 1 but less than 2. And if that's the case, then this will have to be negative, right? So 1 point something 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 that's negative, add a 1 to it, you get a negative point something something something. Now the last thing I want to do is try one more test value. The last test value I'm going to do is 11 and a half. So t equals 11 halves, 11 and 11.5, excuse me. 11.5. Now that's going to give me 23 halves, and so I have 1 plus 2 times the sine of 23 twelfths pi. But what do I know? I know that 23 twelfths is probably somewhere in the third or fourth quadrant where sine is negative. It isn't equal to 0. I don't have to worry about that, and being a negative value means that it's going to be ultimately less than less than negative 1/2. So if 2 sine of 23 twelfths pi is less than negative 1/2, then sine of 23 twelfths pi is less than 1/2, then I know that I'm looking at 1 minus something that is less than 1. And if it's less than 1, I end up getting a positive value. So this answer that I have right here is greater than 1 and will make a positive. This one being a negative, we're looking at left and right. I can now answer the question, and I can say that the particle is moving right. On. Now remember, the velocity is a derivative, which means I'm not going to include the endpoints. So on the two intervals, 0 and 12 are omitted. But I have 7 union with 11. And this is my reasoning, okay? We're now going to take a look at the next question, which was, what is the speed of the particle at t equals 9? So let's find what v of 9 is. We're going to then take the absolute value of that. That's speed. Speed is the absolute value of a velocity value. And we'll have to include direction. So let's find out what we get. V of 9 is going to end up being 1 plus 2 sine, and I'm looking at 9 pi over 6, which is 3 pi over 2. And we know that the sine of 3 pi over 2 is negative 1, so I have 1 plus 2 times negative 1, and that's going to give me a negative 1. But I want the absolute value. So speed is 1 to the left. And because this is an FRQ, I'm going to make sure that I write a sentence. The speed of the particle at t equals 9 is leftward, or leftward. Let's say 1 to the left. So 1, but they didn't give me units. And then the direction to the left to account for the negative. All right, there's the second question. We're now going to go to question number 3, and question number 3 was asking, find the acceleration. Now we know that acceleration is the derivative of velocity. So if my velocity is given as 1 plus 2 sine of pi over 6t, I'm going to find a of t by finding v prime of t. And this will give me 2 times, and now I'm going to use the chain rule, cosine of pi over 6 t times the derivative of pi over 6t, which is pi over 6. Simplifying that gives me the pi over 3 cosine of pi over 6t. There is my acceleration formula, a of t. Once again, no units were given. That's the best I can do. We're now going to plug in 6. What is the acceleration at 6? Well, this is pi over 3 times the cosine, and when I plug in the 6, I get 6 pi over 6, which is just pi. And we know that the cosine of pi is -1, so my acceleration at 6 has to be negative pi over 3. Alrighty, so we now have our acceleration formula, and we have our acceleration. So let's just write our answer down. The acceleration formula or function is a of t equals pi over 3 cosine pi over 6t, and subsequently the acceleration at 6 is going to be negative pi over 3. And there's my answer to C. The last one is the speed of the particle increasing or decreasing at t equals 6? Now, in order to answer this question, I am going to have to first find out what is v of 6. Because speed, decreasing or increasing, is a direct result of both velocity and acceleration at that time. So, what do we get? 1 plus 2 sine, once again multiplying and putting in the 6 right here, I end up getting the sine of pi. But the sine of pi is 0, which means that v of 6 is 1. Notice that the velocity at 6 and the acceleration at 6 have opposite signs, and that's ultimately how I'm going to write this. When velocity and acceleration have opposite signs, the speed is decreasing. So here we go. The speed of the particle is decreasing at t equals 6 because. Now I like to be very, very specific. I like to make sure that when the reader is reading my work, they know exactly what's happening. So I'm going to put a little bit more than I might need to. I'm going to say that v of 6 is greater than 0 and a of 6 is less than 0. So a of t and v of t have opposite signs. That's my justification and my reasoning and my answer. The speed of the particle is decreasing at t equals 6 because the velocity at 6 is greater than 0 and the acceleration of 6 is less than 0, so a of t and v of t have opposite signs. And there we have our FRQ involving particle motion. I hope this has helped. I hope you enjoy the video. Please remember to click like if you found this to be useful. If, however, you have constructive criticism, please let me know so that I may improve. Thank you very much, Hornets. I hope this has helped you. Be well and be safe. Take care. And thank you very much. Bye-bye now.